Okay, you're welcome back to our class for today. Now, I want to talk about sorts. What are sorts? Okay, in numeration, we have numbers that we refer to as rational numbers. Okay, so these rational numbers are numbers that we can express as exact fractions. Okay, so a value like 5, we know what 5 is. If I say give me 5 oranges, you know how many 5 is exactly. Okay, so numbers like 7 over 2, that's 3.5, it has an exact value. Numbers like 0.33, these are rational numbers. Okay, they either have exact values or recurring decimals, so they are rational numbers. But there are numbers that don't have exact values. We refer to those ones as irrational or non-rational numbers. Now, when we're referring to these non-rational numbers, they don't have exact values. For example, pi, sometimes you assume pi to be 3.142 or 22 over 7, but those are just estimates, okay? So pi is actually 3.14159 and so on. Okay, good. It continues without repeating itself. That means it doesn't have a recurring decimal and it doesn't terminate, it doesn't end, which means it doesn't have an exact value. Okay, so numbers like this are referred to as what? Non-rational numbers. Okay, good. Not pi is not the only non-rational numbers. Now, if I have something like root 2, that's the square root of 2, I might be getting something like 1.41428 and so on. It does not repeat itself, it does not terminate. So these kind of numbers are also referred to as what? Non-rational numbers. So where does surd come in? Now, when we have non-rational numbers, which are expressed as roots of numbers, like root 5, root 7, all these are what? Non-rational numbers. Okay, let's see. Root 5, that'll be 2 point, I'm coming. So we have square root of 5. Okay, that'll be 2.236 and so 2.236 and so on. Then the same thing, square root of 7, root 7, that will be 2.64575 and so on. They don't repeat themselves and they don't terminate. So sorts are non-rational numbers that can be expressed as square root of whole values or square root of whole numbers. Okay, so these are sorts. Okay, now why do we need sorts? Well, sorts are important because they help us. Now imagine trying to approximate this. Now, getting the approximate is good, but it may not always be very accurate. Sometimes it's better to carry out calculations or more accurate calculations using the sort form. If I'm solving a problem using root 2 instead of 1.414, I'm very likely to get to a more accurate solution or a more accurate answer than when I use 1.414. Okay, now if we're actually going to carry out calculations involving sorts, okay, then we need to know rules of operations using sorts. Rules of sorts. Now, in summary, I need you to remember this. All perfect squares are not sorts. So root 9 is equal to 3. In this case, I'm just taking 3. You know, it's plus 3 or minus 3. Okay? Now, root 49 is equal to 7. So these are perfect squares. They are not sorts. So whenever you say something like 1 squared, 1, 2 squared, 4, 5 squared, 25. Square root of these perfect squares are not sorts. The numbers that are sorted are square root of numbers that are not perfect squares. Okay? So let's assume that m and n are sorts. Root m and root n are sorts. The rules of sorts say square root of m times square root of n is same thing as square root of m times n. Also, square root of m divided by square root of n is equal to square root of, okay, let me write it this way, square root of m over n. Okay, now also remember, if you have root m squared is equal to n, because the square root will cancel out the square. Okay, so root m squared is equal to m. Good. Now, if you have something like, if you have like surds, what are like surds? Okay, if I have something like a root m, okay, so if I have a root m, let me say plus b root m. These are like surds. How are they like surds? Both of them have the same surd m. So you just have to add the coefficient, that's the values of a and b. So that will be a plus b root m. So if you have something like 2 root m plus 3 root m, that will be 2 plus 3, 5 root m. Do you understand that? Okay. So if these are some of the basic rules. As we proceed, I will still let you know on other rules that can be applied. Okay. For instance, if I have something like a root m times b root n, we can actually multiply this. So I'll use a to multiply b and use this surd to multiply this surd, which will be equal to ab root mn. For instance, 2 root 3 times 5 root 2. I will say 2 times 10, 2 times 5, 10 root 3 times 2, 6. So this times this will give us this. These are some of the basic rules of surds. Now, we'll proceed with solving some problems on surds.